Hi, everyone. My name is Nellie Gustafsson, and I'm a product manager leading the Synapse Data Science experiences in Microsoft Fabric. In this video, I'm going to walk through a key end-to-end data science scenario, and I'm going to show you how Microsoft Fabric simplifies the way that you can get predictive business insights from your data.
You're probably familiar with the data science process. This is an iterative process and typically starts with wanting to answer a question. For example, questions like, which customers will churn in the coming month? Or which of these transactions is fraudulent? This is a step where data scientists need to collaborate with stakeholders like analysts and business users. In Microsoft Fabric, this collaboration is much easier since stakeholders who work in Power BI and analyze the data can seamlessly share reports and underlying datasets with data scientists. Additionally, data engineering teams have prepared lakehouses that can be shared. Microsoft Fabric makes these handoffs much smoother. Data scientists can use notebooks in Microsoft Fabric to author code, explore, and prepare data. A lot of time is typically spent on this step. In Microsoft Fabric, we also offer low-code tools like Data Wrangler, which data scientists can use to speed up tedious steps like data cleansing and preparation. And once the data is in a good shape, you can start defining features for machine learning model training. Model training requires a lot of experimentation. There is often a need to try out different combinations of parameters and algorithms. Thanks to the built-in MLflow tracking capabilities in Microsoft Fabric, experimentation can easily be done with standard MLflow APIs. And the rich Synapse ML library also provides a large variety of easy-to-use machine learning tools for distributed and scalable machine learning on Spark. Throughout this process, there is a constant need for communication between data science users and stakeholders. Again, thanks to Microsoft Fabric being a unified platform for the various roles involved in an analytics project, sharing insights and collaborating is very seamless. And once the best machine learning model has been evaluated and approved for deployment, the scalable Spark predict function helps to score large batches of predictions. There are multiple ways in which automation can happen. You can schedule individual notebooks to run on a regular basis as new data lands in a lakehouse. Notebooks and Spark jobs can also run as data pipeline activities. The predicted values can be stored in lakehouses in Delta Parquet files. This makes serving to Power BI very simple with a Power BI Direct Lake Mode functionality. Without any data loads, the predicted values in a lakehouse can immediately be made available to Power BI reports. As new data is scored, new predicted values are automatically available in these reports so that analysts and other business users can consume them. Now, let's take a look at a demo of this core end-to-end data science scenario in Microsoft Fabric. We are going to look at one of the key end-to-end data science scenarios in Microsoft Fabric. Here, I'm in my workspace and I've created a notebook. Here, we are building machine learning models on Spark for predicting taxi trip durations. And we will then seamlessly serve predictions for consumption from BI reports without any data movement or extra steps. With our notebook experiences, data scientists can quickly get started solving problems using machine learning tools. The raw taxi trip data that we're going to use is in our lakehouse and contains 34 million records. This data contains details about taxi trips, and we are interested in being able to predict the duration of a trip given a set of known factors. This could help us plan and optimize trips better. We are going to take a sample of this data and do exploratory data analysis using Python and popular visualization libraries. For example, we can learn more about our data by looking at the distribution of the trip durations. We can analyze this by passenger count and look at the distribution of passenger counts per trip. In this way, we can detect relationships and correlations in our dataset. We can analyze peak hours during a day and peak days of the week. This also helps us detect outliers and missing values to filter out. And once we are done cleaning up the dataset, we can save the prepared dataset back to the lakehouse. Microsoft Fabric also has a built-in MLflow endpoint. This means that you can easily track and manage your machine learning models and experiments with standard MLflow APIs. We are going to read the cleansed and transformed dataset from a delta table in the lakehouse. After some feature engineering and defining hyperparameters, we are ready to train a machine learning model. Here, we are also starting an MLflow run to make sure we capture and track this iteration. We are using Synapse ML and a light GBM regressor to train this model. And finally, we can log the model version. This process will be repeated for another run with a tuned set of hyperparameters. The model and experiment now exist in our workspace as items. If we open the experiment item, we can see the runs that we just created. We can see all the associated files and details about our runs. For example, we can see model signature and environments. It is also possible to save models from runs in this experience. We can also filter runs in a list and compare different runs and customize charts. This makes it easier to evaluate different runs. Similarly, we can take a look at the model item in our workspace. Here, we see two versions of models logged from our notebook. We can see how we can apply models through various experiences and even copy the code for using a model in a notebook. Here in the notebook, we can run model scoring and save the predicted values in a lakehouse table. With the Power BI Direct Lake mode, this table with predicted values automatically becomes part of an auto-generated Power BI dataset. Thanks to this tight integration between Power BI and lakehouses, data science users in Fabric can now easily collaborate and continuously share results and data from the data science process with stakeholders like analysts and business users. The lakehouse is not only a place to store batch predictive values in this case, but it's also a bridge that helps collaboration. Without any data loading, data movement, or manual steps, this enriched data is now seamlessly served into Power BI reports. And if we want to automate this by scheduling Spark jobs or notebooks to run on a regular basis, it automatically refreshes the Power BI reports as well. The consumers of the reports can now get the latest enriched data to analyze with zero lead time.
I hope this was useful and that you have a better understanding of how data science in Microsoft Fabric helps to simplify the process. We'll post links so that you can try this out on your own. Please let us know what you think, and stay tuned for many more exciting data science updates. Thank you for watching.